in this video 6.4 from the textbook, we're assessing for normality. And so in the previous videos, we looked at normal distribution curves, we looked at finding the area underneath the curve. And so now what this section is showing us is to create these normal probability plots where we have an observed value and measured against a normal score and see whether or not the plot that we get is linear or not linear. If it's linear, that means the data is normally distributed. If it's not linear, that means it is not normally distributed. This information is very, very useful when it comes to other statistical um, data analysis that we need to perform. Normally, it requires a normally distributed data set, and so this test is just a really wonderful way of trying to get to that answer, whether or not it's normally distributed. So that's what this text box is saying, and I have a problem here that we will do together to illustrate this point. So 6.129 in the textbook, we have a table here listed with different values, and we are instructed to create this normal probability plot and to determine whether or not the data here is normally distributed. So to begin, we have to put this data set in order, and then after we do that, we have to go to a table in the textbook, table 3, and look up the normal score. So there will be the vertical axis here. So the horizontal axis is what's given in the problem, and then the normal scores are given in the table. So I had already taken some time to create this table, and so 6.129, that's the problem number, and then these are all the listed values from this table here that is in order. You can always verify that I did that correctly. And then these normal scores that are associated with the order pair. And so you may say, where did I get this number from? I will take you straight to this place. This is table 3 in the textbook. And so the way we use this table is, given a certain value of n, we can determine the scores for the observations that were given. So in our example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 numbers or 14 observations that were given. So n equals 14. So we look, this is the row of n's. So we look for 14, which is here, and we are given negative 1.71 all the way to positive 1.71. And so all I did was copy this, and I written it out here. So this is our x axis, this is our y axis. And then we would plot something like this. We'll label the axes. This would be finishing times in seconds. Normal score will be still the same, from -3 to +3. So this y-axis will stay the same. The only thing that will change or be different for us will be the horizontal axis, and then we will plot. So we would match, just like in regular graphing. We would look up, we will find 93 on the number line, and then go up negative 7.1, and then we will plot that point, and then we'll do that for all the remaining points, and then we would look at the graph and see. Unfortunately, I won't be able to create the graph with the PowerPoint, but you will create, I already taken the time to do this by hand, and once you do, you should see a linear plot. And so to answer this question on whether this data set is normally distributed or not, we would say yes. And the reason being is because for the normal probability plot, the line is linear. And so that's how you would assess a data set, a set of observations and values, measurements for normality. Okay, thank you.